The diagram above shows the curve C with the parametric equations x equals cos t, 8 cos t, and y equals 4 sine 2t, where t is between 0 and pi over 2. The point P lies on the curve C and has got the coordinates 4, 2 root 3. Part A, find the value of t at the point P. So we know at point P, x equals 4 and y equals 2 root 3. So let's take that 4 first of all and substitute it in to our x equation. Excuse me. I can divide both sides by 8. I can do cos inverse. So cos inverse of a half. And when I do that, I get pi over 3, which is in the interval required. And just double check this, just substitute it into the y function as well to doubly make sure. So y equals 4 times sine of 2 times pi over 3. And yes, that does give us 2 root 3. So the answer to part A is pi over 3. The line L is normal to the curve at point P. So this line L is perpendicular to the curve at that point. We need to show that the equation for L is y equals excuse me, minus x root 3 plus 6 root 3. So, equation of the normal. So we're going to first work out the gradient of the tangent and then do negative reciprocal. So gradient of the tangent we're going to find by doing our gradient function, which when we're in terms of parametric equations, we'll write as dy by dt divided by dx by dt. When I differentiate my x function, differentiating 8 cos t, well, cos differentiates to be minus sine. So I'll get minus 8 sine t. Now differentiating the y function, and to be a little bit careful here because we're going to have to use the chain rule for this. First of all, differentiating the outside part, we'll get cos, because sine differentiates to be cos. But then, because of the 2 on the inside here, I'm going to have to multiply by the derivative of that 2t, which is 2. So times this by 2, and it will actually be 8 cos 2t. So that is my gradient function. We can see straight away that the 8's are going to cancel out. And I'll get minus cos 2t over sine t. It's a little bit simpler. Right, that's our gradient function. At point P, I know that t is pi over 3. We saw that in part A of the question. So therefore, let's substitute that into our gradient function. When we substitute that in, we get 1 over root 3. So therefore, the gradient of the normal is the negative reciprocal of that, which will be minus root 3. We can now do y equals mx plus c. We know it's going through the point P. So let's substitute our y in and our x. And we find that c is going to be 6 root 3. So our equation then is y equals minus root 3x plus 6 root 3, which was what we needed to show. So that's part B. Part C. The finite region R is enclosed by the curve C the x-axis and the line x equals 4 as shown in the diagram above. Show the area of R is given by the integral from pi over 3 to pi over 2, 64 sine squared cos t dt. So usually I would find this integral, this area, by integrating y with respect to x between my lower limit of 0 and my upper limit of 4. That's what I would usually do. But obviously in this case here we have got parametric equations in terms of t, not in terms of x. So instead of doing y with respect to x, I'm going to do y times dx by dt. And I need to know what are my, what's the t limit when x equals 0 and what's the t limit when x equals 4. So let's do those limits first. So when x is 0, so let's go to our x equation. X is 0 equals 8 times cos t. So cos t equals 0. So t would have to be pi over 2. So our lower limit is pi over 2. The upper limit, when x equals 4, well, we already know what t is for this. We did it in part A of the question. We found the value of t at point P. So we know it's pi over 3. That's our upper limit. Right, so that's the limits sorted. Let's now substitute our y in. So remember our y is 4 sine 2t. And dx by dt, we did differentiate this a few moments ago. Differentiating the 8 cos t gives minus 8 sine t. Now, let's tidy this up a little bit. The 4 times the 8 is 32. Whilst I'm at it as well, I'm going to swap the limits around with that negative. Just so I've got the bigger limit on the top. The pi over 2 is bigger than the pi over 3, so it's more useful. It's simpler to have that on the top. And I can swap those around by getting rid of that negative. Then, like I say, the 4 times the 8 is the 32. And I've got the sine 2t sine t. Still not quite in the form that I was asked to show. So it's starting to do a bit of work. I need to get rid of this sine 2t, which is fine because I know that sine 2t is the same thing as 2 sine t cos t. They are the same. So simplifying this, then I've got the 32 times the 2 is 64. And then I've got the sine t. The sine t times the sine t is sine squared t. And then I've got the cos t. And that's what I needed to show for part C. Finally, for part D, use this integral to find the area of R, giving your answer in the form a plus b root 3. So let's take this integral. I'm going to take the 64 outside the integral, just to make my life a little bit easier. And I'm going to do one other little change here. I'm going to rewrite it so that I have a cos at the front. And this is my sine squared. So all I'm doing here is just taking the 64 on the outside, and then I'm swapping these around. It doesn't matter which way around we're multiplying these. And then I'm writing the sine squared as sine t all squared. The reason I'm doing that is because I can spot a derivative here. Remember, the idea of spotting a derivative is when you have a situation where you have a derivative of a function where the function is inside a power and you need to integrate it, then that's really useful because you can ignore the derivative completely and then add 1 to the power and divide by the new power. And that's exactly what we're going to do here, because I noticed that we've got a sine t on the inside there. And I know that sine differentiates to give cos. So I can ignore the cos completely. I can then add 1 to the power, divide by the new power. So that's been integrated. All I need to do now is substitute the limits in. So 1/3 sine pi over 2 cubed minus 1/3 sine pi over 3 cubed. Work out what that is, multiply it by 64, and I get 64 over 3 minus 8 root 3. And that is my answer for part D.